Continuing in chapter 10, today we are going to look at inscribed angles. So let's go back to the two types of angles that we found in circles so far. First one is our central angle. Remember, a central angle is an angle whose vertex is on the center of the circle. So a central angle has to have their vertex on the center. Now, what do we know about central angles? Central angles are the same measure as the arc they create. Okay, so what that tells me then is if I know this arc is 90 degrees, then this would be 90 degrees. Okay, that central angle would be 90 degrees. They are equal to the arc that they create. Now, second one then, let's talk about the inscribed angle. The inscribed angle is an angle whose vertex is on the circle. So notice vertex B is not on the center anymore, it's on the circle itself. Now, what do we know about inscribed angles? We know that inscribed angles are half the measure of the arc they create. So if we go back to this and let's say this is 90 here, then half of 90 would make this angle 45 degrees. Okay? So inscribed angles are half the measure of the arc they create. All right. So how does that help us? Well, let's try a couple. So I start off, I notice that I have an inscribed angle here of QRT, and it's 50 degrees. So the arc that it opens to would be 100 degrees because it is 2 times the angle, and that equals the 100 degrees. Likewise, we know RS is 48 degrees for the arc, so the inscribed angle would be half that, which is 24 degrees. So angle T would be 24 degrees. But I'm also asked for one additional thing. I am asked for arc QR. Now notice we don't have an inscribed angle, we don't have a central angle to get that. But something I do notice, I notice that TR is a diameter. And if I know TR is a diameter, then I know the arc TQ plus the arc QR would equal 180 degrees because that is the arc together that's opening up to the diameter. So therefore, if I know QT is 100 and I'm looking for the measure of arc QR, then I know that has to be 80 degrees. Okay, let's try another one. So here I look at this and they want me to find arc BPC. Now, if you notice, arc BPC is made up of the diameter. So once again, BC is a diameter. So once I know that, then the arc BPC has to be 180 degrees because it has to be that semicircle. Now, if we look then, we notice that angle A is what I'm looking for, has endpoints of and open up to that arc BPC, so the inscribed angle would be half of that, which would be 90 degrees. Okay? So that's how we use those things to find some different measurements. Now, let's go through a couple rules that we know here. Inscribing a right triangle, if the endpoints of an inscribed angle form a diameter, that's a key. The endpoints form a diameter. So endpoints of an inscribed angle form a diameter. Then the inscribed angle is a right angle. So let's look at this here. If we look on this first one, I notice that the inscribed angle ABC forms the diameter AC. This is my diameter. So that means that angle B would have to be a right angle. Okay, so then let's use that now. So if I know that, I know here, I know KM. I know that is a diameter. So that means the inscribed angle that opens to that must open to the diameter, which means that would be 90 degrees for X. Now, once I know that's 90 degrees, then to find Y, I simply can take the triangle sum theorem. 90 plus 40 plus Y has to equal 180. So Y must equal 50 degrees. Okay? So that's how we can use that. So again, if the endpoints of an inscribed angle form a diameter, then the inscribed angle is a right angle. Next, we have congruent inscribed angles. If two inscribed angles in a circle have the same endpoints, okay, that's the key, has the same endpoints, then the inscribed angles are congruent. So let's take a look how this looks. So if I'm looking here at angle ADB, you'll notice they end at AB, or they create the arc AB. Likewise, if I look here at ACB, they have the exact same endpoints. So what that tells me is that tells me that the measure of angle ADB has to equal the measure of angle ACB. Okay, so then how do we use that? Well, first thing I know is I know GEH has the endpoints of G and H, but I also know GFH has the exact same endpoints. So therefore, angle F has to be congruent to angle E, which would be 75 degrees. Then we want to know what would be that arc. So what would be the arc GH? So from G to H, I have my inscribed angle of 75. So the arc that would be there would be 2 times 75, which would be 150 degrees. So if two inscribed angles in a circle have the same endpoints, then those inscribed angles are congruent. Okay, last one here. We have inscribing a quadrilateral. Remember, a quadrilateral is simply a four-sided polygon. Okay, so inscribing a quadrilateral, the opposite angles of a quadrilateral, okay, the opposite angles of the quadrilateral inscribed in a circle are supplementary, meaning they add to equal 180 degrees. Now, why is that? Well, let's think for a second. If I'm looking at angle E and angle G, they are opposite angles of an inscribed quadrilateral. Notice they both have the endpoints DF. So if I look, angle E opens up to all of that, okay? I also see that angle G opens up to all of that. So if you look at that, the full circle is covered, right, between those two angles. And G is half of arc DEF, and angle E is half of arc FGD, but together they would make the whole triangle, or the whole circle. So they are technically half of the full circle, which is 180, which would make them supplementary. So how do we use this then? Well, to find C here, I'm looking at U and S. So what I know is that those two things together are going to add together to equal 180. So that's going to give me 3C minus 6 is 180. So 3, 6 equals 186. So C would be 62. Okay, likewise, I know that T and V would be supplementary, so 10x plus 8x has to equal 180. So 18x equals 180, so x must be 10. Okay, and that's what we do when we get our inscribed quadrilateral in a circle. The opposite angles are going to be supplementary.